All right, so here are some word problems involving circumference and arc length. So the first one says a 2 foot wide circular track for a camera dolly is set up for a movie scene. The two rails of the track form concentric circles, so circles with the same center. The radius of the inner circle is 8 feet. How much farther does a wheel on the outer rail travel than a wheel on the inner of the track? This should say inner rail of the track. In one turn, round to one decimal. So one turn means circumference, right? So there's a distance that each wheel travels. So here's the inner wheel, here's the outer wheel. Obviously, because the outer one's farther away, it's going to be a little bit longer. How much longer is it? So again, comparing circumferences. Now, each circle has its own radius. So yes, the inner circle has a radius of 8 feet. The outer circle goes a little bit further, right? So it goes 8 feet plus the 2, and 8 plus 2 gives you a radius of 10 feet. So to find how much further does the outer wheel travel, you need to take the circumference of the outer wheel and subtract the circumference of the inner wheel. So that's going to be 2 pi, circumference is 2 pi r. So that's 2 pi times 10 minus 2 pi times 8. And that's just going to be 20 pi minus 16 pi. That's just going to be 20 minus 16 is 4 pi. Pi is like a variable, right? So this is going to be my answer. It says round to one decimal. So when I go to Desmos Graphing Calculator, I'm going to clear all this for us, and I'm going to enter 4 pi. Remember, you can go 4 pi or find the pi button. That's 12.56 round to one decimal. So this 6 rounds the 5 up to a 6. 12.6. This is circumference. So circumference is length just in units. So when I answer this, 12.6, it's going to be just units. So these are in feet. So it's also going to be in feet. And there we go. All right, next problem here. It says a hamster wheel has a 7-inch diameter. How many feet will a hamster wheel travel in 100 revolutions of the wheel round to the nearest whole foot? So a couple things, okay? Number one, this revolutions idea means circumferences, right? Each revolution is one circumference, so this is 100 circumferences. So once you find the circumference and multiply by 100, there you go. But notice it says round to the nearest whole foot. It gives us the diameter in inches. So keep in mind that in the end, we're going to have to identify that 1 foot equals 12 inches and do a little unit conversion. Okay, but again, this is still circumference. So the circumference of any circle is 2 pi r. If your diameter is 7, to find your radius, take half of 7. That's 3.5. So my circumference is 2 pi times 3.5. So I want 100 of them. So 100 circumferences is going to be 100 times 2 times 3.5 is 7 pi. So this is going to be 700 pi, okay? And that's going to be in inches. Well, if 1 foot is 12 inches, then how many feet are 700 pi inches? So to find how many feet, you're going to take the 700 pi and you're going to divide by the 12 inches, right? Take 700 pi inches, divide by 12 inches, and that'll give you how many feet. And this is all going to be done without a calculator so far because I want to avoid rounding. Now I will type all this in and I will round. 700 pi divided by 12. 700 pi divided by 12. And there it is, how many feet. It says round to the nearest whole foot. So we're looking at where the 3 is. The 2 leaves the 3 alone. That's 183 feet. So when you type this in, again, it is circumference. So it's just units, 183. And that would be in feet again, not feet squared, feet. Excellent. Next question. The minute hand on a clock is 5 inches long. How far does the end of the minute hand travel during a 20-minute interval round to the nearest tenth? Okay, so what we're doing here is this is like an arc length, okay? So if I take this clock, right, here's my minute hand. This is 5 inches long. As it moves 20 minutes, right? So 20 minutes is, 5, 10, 15. This would be 20 minutes. So the question is, how long is that arc length? L. All right. Well, the arc length formula is the angle divided by 360 times the circumference. Now, there's a catch here, though, right? On a clock, right? We don't think of a clock as 360 degrees. We think of a clock as 60 minutes. What one rotation is 60 minutes. So instead of thinking it like this, angle out of 360, I'm going to say, what's the minutes out of 60 minutes? Okay? So if that makes sense to you. So again, first thing I'll do is I'll find the circumference. So the circumference of this clock is 2 pi r. Your minute hand acts as the radius r. So that's 5. So your circumference is 10 pi. And then we'll plug that into the formula. So to find the arc length, again, we're going to take the minutes that we're traveling, 20 out of 60 minutes. Same kind of idea. It's the same ratio as degrees and 360 degrees. So 20 out of 60 times 10 pi. And again, I'll multiply this out and I'll round to the nearest tenth. So I'm going to go to 20 over 60 times 10 pi. 20 divided by 60 times 10 pi. 10.47, again, round to one decimal. So the 7 rounds the 4 up to a 5. 10.5. And this is arc length. So arc length is in inches. 10.5 inches. Let's find inches. There we go. So again, that one is a little tricky just because I used time instead of degrees. Okay, same kind of idea. All right, last one here. Okay, this problem says a landscape architect is constructing a curved path through a rectangular yard. The curved path consists of two 90-degree arcs. He, not Hugh, he plans to edge the two sides of the path with plastic edging. Let me tell you, plastic edging, the worst. I have this little walkway in my backyard. Every year it pops up. I got to dig it out, put it back down. It's so hard to work with. So not for me. Excuse me. What is the total length of plastic edging he will need? Round your answer to the nearest tenth of a meter. So the idea is the following, right? So we have two identical sides of this picture. So let's do this left side here. So we have an outer part to the walkway that needs to be edged and an inner part that needs to be edged. And again, I hope you can see that this space here is identical to this space up here. So we're going to find these two lengths and we're going to double them because there's a set of two. Now, the 90-degree arcs come from this 90-degree angle. If I continued this circle, right, this piece would just be an arc in that circle. So I want to find this length. I'll call this the length of the inner and the length of the outer arc. All right, so let's start with the inner arc first. So obviously, arc length is the angle out of 360 times the circumference. Again, the circumference is 2 pi r, right? So find the circumference. So my radius is this 4, right? Again, if you visualize this circle, the 4 goes from the center out to the circle. So 2 pi times 4, so that's 8 pi. So then 2, to find the arc length of the inner edging, you're going to do the angle, which is 90 out of 360 times 8 pi. Okay? And we're going to multiply that by 2 because that's going to be, signifying the two inner paths, one here and one up there. Okay? Because this is the same length of the inner right here. All right, so let's go. Let's wait on that. Okay? So now let's find the length of the outer edge. Again, same kind of process, right? Angle out of 360 times the circumference. So to find the circumference, I need 2 pi r. Now, be careful here, right? Now this radius goes 4 and then all the way across the sidewalk. So that's 4 and 2. So that's a radius of 6. So my circumference is 2 pi times 6, which is 12 pi. And now to find my arc length of the outer, I need to take, again, 90 degrees. It's still a 90-degree arc. It's just a bigger circle out of 360 times the circumference of 12 pi. And again, we'll multiply that by 2. So if I take a picture, I could try to do all this together so that it wouldn't, I wouldn't have to round it all. So let's do that real fast, okay? All right, so I took a picture. So we're going to add all that together. So we're doing uh, 90 divided by 360 times, it's 8 pi times 2. 8 times 2 is 16 pi, right? Plus 90 divided by 360 times, and it's 12 pi times 2. That's just 24 pi. All right, and there we go. I got 31.4. One, it says nearest tenth. So the one leaves the four the same, 31.4, and I believe it's in meters. And that's how much I'll need to cover the entire path, top and bottom. Yeah, 31.4 meters. 31.4, and that would be in. There we go. All right. So again, best of luck on this. Hopefully, the word problems I provide you, you're able to do. Just make sure you identify the picture, what you need to find, and just break it down like this. All right. Thanks for watching. See you next time.